Hey guys, welcome back to Daddy and Daughter Electronics. Anywho, so today we're going to be making a GoPro remote for jumper planes at the drop zone near us.
So why are we doing this, Catherine? Tell us a little bit more about it.
My dad's a jumper pilot. When he's flying and people want the strut cam, he kind of has to do stuff like he has to listen to radio calls from the air traffic control. He also has to fly the plane to where the jumpers want to go. So yeah, it gets a little hectic that he forgets to turn on the strut cam.
Is it just me or is it everybody else too?
Oh, well, yes, it is like everyone else.
So what are we trying to do? We're trying to make it automatic so people don't forget. So do you have a design for this? So this is Catherine's self-titled super professional drawing. So it's going to look something like this. We're going to have a little screen, and at the bottom of this box that has the screen in it, we're going to have 4 switches. One that turns the remote on and off, one that activates the automatic mode, and then 2 switches for the manual mode. One to turn on the camera and one to begin recording. Alright, so Catherine, what are we going to use for this particular project? In the past, we've always used our little AVR chips for many things, including the awesome Catherine sign, which is not currently illuminated, but we did on a recent episode. So what are we going to use for this one? Are we going to use an AVR chip again?
No.
Alright, what are we going to use instead?
We're using an ESP8266 breakout.
Alright, so we're going to use an Adafruit ESP8266 Huzzah board.
I love that name.
So why are we using that instead of the AVR?
Because this, unlike the AVR, connects to the Wi-Fi.
Alright, so if we look real closely at that chip, can we see an antenna on the chip?
Oh, yeah, it's right there.
Alright, so let me zoom in on that for the viewers at home. Alright, so that's the ESP8266 chip. And you can see at the bottom the squiggly circuit trace. That is the wireless antenna. Sometimes people call this an IoT chip. What's that stand for, Catherine?
IoT chip. It means it's a Internet of Things chip.
Alright, so we are also going to have a display, and we're going to have a slightly different kind of a display this time. Alright, so we're going to use one of these. That's an OLED display. And what that is it's a display made of a bunch of little LEDs. So it's not a backlit display. They're really nice because they're very compact. They're not as nice because they're not super cheap. But that's what we're going to use. Now, we're going to use someone else's design. I actually put some stuff out on the internet trying to gauge interest to see if other people would also be interested in a remote like this. And I got some responses from people saying, well, I already built something kind of like that. And the only difference is what we're going to do is we're going to add this automatic functionality to some existing stuff. So we're going to take what someone else has already done and just build on it a little bit. So how are we going to do this automatic mode, Catherine? What are we going to use for that?
This amazing pressurized sensor.
Alright, so is that a temperature, humidity, and pressure sensor?
Yes, that's what I just said.
Okay, so what we're going to do is we're going to use that sensor to try to detect when the camera should come on and when it should start recording. So how's that going to work, Catherine? Tell me a little bit more about that.
Okay, so we're gonna have the remote and the pressure on the outside of the plane is less than the air pressure on the inside of the plane. So when the door opens, it's gonna see that the pressure was lowered, and it's gonna turn on the GoPro.
Right. So when you open the door for a jump plane, the pressure dips down real quickly for a split second, and we're going to try to detect that, and we will use that to turn the recording on. What about turning the camera on? What are we going to use to turn the camera on? As the jump plane goes up, what happens to the pressure?
It gets less.
Why is that?
It's because the air from your head all the way to space is pushing down on you.
And as you go up, there's less air?
Yes, between you and space.
So then the pressure goes down.
Yes.
Does it go down about an inch of mercury per 1,000 feet?
How should I know?
Well, I don't know how you would know, but the answer is yes, approximately. That's something pilots know. That's kind of the overview for our design. And did you select anything for switches?
Oh yes, I selected a fine thing for switches. This is for the manual and auto switches. This really nice blue color that matches my dad's shirt.
All right.
And then this is for the on and off switch.
That's kind of the overview. So we're going to set things up on a breadboard, and we're going to try to program our chip, and we're going to try to reproduce what other people have already done. And then from there, we are going to
Wing it.
wing it. Now, from there, we're going to add on some functionality, and we'll probably build a nice case. Are we going to 3D print or make it out of wood?
I want to 3D print it. This is electronics, not woodworking show.
Do you know of any woodworking shows?
Oh yes, I do. Let's see, what is it called? Two Phillips, two Shopsmiths?
That's just kind of an overview of what we have coming up. Now, what's the place that we're building this stuff for?
Above the Pocono Skydivers.
And what's awesome about Above the Pocono Skydivers?
It has the person that holds the world record of most skydives.
And do you know about how many skydives does he have?
About 43,000, I think.
Over 43,000.
Yeah.
What else is awesome about this drop zone? Do they have the most handsome jump pilots?
Yeah.
And do they have talented young ladies that work there?
Well, yeah.
Next time we're going to start building our remote, but that's all for this time.
Thanks for watching Daddy and Daughter Electronics.